Advent of Code, Day 3. Less than a minute away. I'm ready to go. Got my VS Code ready, got empty input, empty file ready, Quokka running. I got less than a minute off. Yesterday's challenge was pretty good. Not expecting it to get crazy difficult, at least until the... I'm not expecting the difficulty to spike, let's say, at least until day 5 plus, and then the real difficult ones usually day 15. So, should be an easy breezy 1, 2, and done. Assuming I don't make any obvious blunders. Let's hope that. Oh, math. That looks scary. Considering the following corrupted memory. Oh no. Okay, let me get my input. Delicious. So there's a blank line. So it seems like each line is input and it gets to process. It's hard to tell. Okay. So yeah, we're doing things to get a result of things. So we're doing things corrupted. Considering the following subsection. Okay, great. So this is our example. Gotta do some fun parsing. That's awesome. Only the 4 highlighted sections adding up and do the thing. Great. Scan the corrupted memory for uncorrupted mul instructions. Okay, so if I could just do some regex. Look for mul parenthesis digit comma digit. Oh, look at these bad ones. No spaces, gotta be a comma, gotta be a closing, gotta start with mul. Okay, let's go for that. Cost matches equals data. So what is this? Boy, it's been a long time since I've done this. I think I write the regex, then ABC. I'm just gonna do the data one. Oh, it's been a while. Match. Okay, match is the thing, and we want match all. So for regex mul parentheses, any number of digits, comma, any number of digits, closing parentheses. Let's see what matches we get. Colorful non-global. Whoops daisy. None? None. Ignore case. To my favorite regex fixing site, Regex 101. Let's see how badly I have goofed. Yeah, it looks valid. My regex there. ECMAScript. Here's my string. Come on. Yeah, regex matches that. Okay, sure, fine. Match all is doing something that I don't know. I don't use match all a lot. Okay, good enough. So from this, I can just do normal basic parsing. So what do I do with these things? I add up the results of the multiplications. Is that it? Okay, add up the results of the multiplications. So const results equals matches match. And if we look at match, we can see it. Then we'll split by the opening. Oh, one split by the closing. And split by the comma. Map both to a number. A, B equals, and then return A times B. Then we'll have results and we'll sum them together. Return these. We have a number. We have another number. Let's see it. Boom. Okay. Part 2. The do enables future. The don't disables future. Only the most recent, at the beginning of the program, malls are enabled. Okay, so I detect these calls, and that triggers where they stop and start. I can easily do that. Let's break it into a two. I said easily, but it's gonna be a little indexing of stuff. Um, could I do it in here in the same regex, or will I have to be weird about it? So I just need to match one thing or another thing. Right? I'm trying to remember how we do that in regex land. How do we do that in regex land? Do parentheses. I feel like this is not how we do that in regex land. These need to be groups. There we go. Yeah, these need to be groups. And I don't think my example has one, so let's put this in my example. Okay, I'm getting it. So now I just need to do the other groupy thing. So parentheses, and then don't escape them again. Okay, we got it. Now we just do flags. Let enabled equals true, and then when I don't get them, I just return zeros. 11 it, 11 it, 11 it. So if match starts with do, then hey, if match starts with, well, it's basically a quality check here. Enables equals match equals do. There we go. And then if enabled, return, do this normal stuff. Braces, else return 0. Ooh, I got a nan. Oh no, what have I done? Oh, I should do a thing. Yeah. If, well, once you enable, actually, no, you don't do anything. Return 0. You don't count for stuff. 48 is not equal to true, but 48 is what we're looking for. So I think I'm gonna get a number and I'll put it in the machine and it's gonna work. Woo! Nice. Why is it telling me the number now? The last ones was I over 1,000 the previous ones? Come on, leave page. Weird. Personal times. Oh, okay, yeah, I guess it shows your number if you're sub 1,000. That's nice. But yeah, that was part one and part two completed. So I'm gonna get rid of that console log, commit it, and then we'll go through the challenge, how my code did it, refactorings if possible, and how that code does it. I did end up using a little bit of regex here, so I will take that into consideration. Ignore the merge, just had some weird old commits from last year that were preventing me from pushing stuff up. Boom! Day 3, it's in here. Okay, so let's go through the problem. So we're given, at least the story that is, some instructions with some commands in it, and there's a bunch of corrupted stuff in there. But then there's some stuff that's actually important. And our goal is to ignore all the bad stuff and just extract the uncorrupted instructions for multiplying two numbers together. These are valid because they are the characters MUL followed by an opening parenthesis, any number of digits, at least one number of digits though, a comma, another number of digits, that's at least one, and a closing parenthesis. That is considered a valid thing. Valid what? Valid thingamabob of memory. What is it called? A valid multiplication instruction, I suppose. Oh, it even says they're 1 to 3 digits. So If they had thrown in 4-digit ones, they would have been considered illegal and my code wouldn't have worked. But they did. They were very cool about this. So that is what we're looking for. Is all the multiplications. When we find the valid multiplications, we're meant to execute them, then add up the results, like so. So, to go through it manually, first we identify all the multiplications, which I'm just going to do by putting them below their original positions. No, there's another one right here. Oh, that's not a valid one. I almost fell for it. There we go, and these are all the valid multiplications. And what you're supposed to do is you're supposed to perform them and sum up the results. So 2 times 4 is 8. I don't know where I'm going to put this. Put it there under the comma. That's a good enough place. 5 times 5 is 10. No, 5 times 5 is not 10. It's 35 or whatever, right? 25. I don't math all day long. 11 by 8. Definitely don't know that one. 88. 88 and 8 by 5 is 40. So you find them, you perform the multiplication that's being described, and then you add up the results. So it's 8 plus 25 plus 88 plus 40. 161. I'll just shove that in the middle here. Which is what they said our result would be. So understanding that that is how one would manually do the problem when you're not supposed to do it manually, because the input is very big and has many, many, many instructions, and is actually over multiple lines too. So I'm glad my regex handled that. I guess this thing, because I know there are certain symbols that don't cross multiple lines depending on how you do a regex and stuff like that, but this works fine. The second half of it was the fact that there were these instructions that turned them on and turned multiplications off. So I'll go through this one. When you see these, any upcoming multiplications should be considered on or off depending on which ones you see. They start on though, so I'll represent that with a green dot. Multiplications are on. Beautiful green dot. So we're still gonna see them all. So I'll do the same thing. 2, 4. Don't mul 5, 5. Mul, nope, it's not valid. Mul 11, 8. And do finally mul 8, 5. Now, technically, you could go a little fancier here, and as soon as you see the don't, you could just not turn off the parsing of multiplications entirely. That's probably a little bit more efficient way of doing it. If you were kind of inside of the parser, which I was not, I was just using lazy regex. But once you do these, the status of your multiplications, they're all on, and then you hit this one and boom, they're all off from this point forward. Then you hit this one and they're on from this point forward. So if you were to draw kind of like a, where are we? They're on until they hit here, at which point all these ones are off. And then all these ones are back on again. Which means the ones that, well, basically means that these two are off. They are not considered. Which means we only need to worry about the ones that are in the green, which are the two at the very ends. So that's 2, 4, which is already 8. And then 8, 5, which is 40, which ends up being 48. Let's see if that was right. It was 48. I'm trying to think if there's anything more to really break down with these two. I don't believe so. Honestly, this is a relatively nice to follow one. So, that's the problem itself. How did I solve the problem? Well, I use regex. Not the best or not the most approachable thing, but it works. So, I'll explain the regex itself after I explain the code. So, we match for any strings that match in the regex, which we disable our big calls. We're gonna look at them more easily. And we can see it gets us the 4 matches for the regular expression, which are all the valid multiplications. For each of them, then I do some non-regexing, which I could have used regexing for, to basically get the numbers out. So I'll go through each of these steps one by one. So first, I just want to get everything after the opening parenthesis. So I split by it, and then I choose the 1th item. So that's everything after it. But then I don't want anything after the closing one. So I do another split for that. I could have just done a slice and ignored the last character, but that's what I chose. So now we have these ones. And then I want each number as their own string. So I split by comma for that. And as you can see, 11 properly, both digits are in there. But then I wanted them as numbers, so I mapped them to the number constructor like that. And now we have actual numbers. Then I decided to go ahead and deconstruct them because there will always be 2 to A and B, which I did like that. And then I multiplied them together. Finally, once you have all your multiplication results, which you have here, you can sum them together with a reduce, which is a common way to sum up an array of numbers. That's how the part 1 code works. The part 2 code works similar. It builds on it, but then I use more regex to find the do and don't strings, and those go inside the match. So that's how this works. It finds them in order, so it finds the multiply, the don't, the more multiplies, the do, then the last multiply. And then before I started going through them, I have a little enabled flag that tells me if I have multiplication enabled or not. And as soon as I find a match that starts with do, because this could be either do or don't, then I set enabled to whether it says to do or not. So if this is a do, so this is enabling it, this is true, enabled is true. If it's not, and then it's don't, then this expression is false, and enabled is false. Then, since this is technically in my map, where it probably shouldn't be, I need to return a number, so that way it can be reduced later. I could have filtered. Honestly, it didn't matter. Finally, when I do get to something that's not a do or don't, I check if it's enabled first. If it is, do the exact same thing I did before. If it's not, I still need to return 0 because I'm doing this weirdness, which gives us the results, where you have every do and don't replaced by a 0, and every disabled multiplication replaced by a 0. Make that clear when I put this also here. So we can see, there we go, that the enabled multiplication is an 8, but the don't is a 0. Out of the way. The next don't is the next 2 multiplications are also zeros. The do is a 0, and then finally the multiplication after the do, when we are enabled, is back to being a 40. Not the cleanest, but it works. And that's honestly that's the problem. That's how one would solve it. So yeah, now it is a refactoring time, I believe. So first thing we have is we have a lot of good code. Like that. Hey Rask, how's it going? Yeah, it was, everything fell into place. I made no mistakes really, so that's how it always works. Nice. Oh, shame you couldn't find that photo for Rask. That is hilarious. Yeah, glad you gave it a shot. I'm sure you're glad too. Yeah. Sub 1000 Club, welcome. This is the first one I also got sub 1000 in this year too, so yeah, just a little easier to click with. Okay, so refactoring, as with all of these, 50% of it is parsing your input, and the other 50 is doing something with your input. So I think it's the matching and the process. Honestly, I could use part 2 for part 1's code. I think I can. Well, I'll just use it with a flag of like is enableable or something to that degree. I can use it, and the regex is what changes because that's what gets detected. Yes, I'll do that. Function solve data string. Let's think of a really cool Boolean name. Do they have cool words in part 2? Conditional multiplications. That's a great name both for Boolean. Horrible name. I'm just gonna go with it though. Boolean. There we go. And that's literally just going to determine the regex that's used. So I should be able to use the part 2 code in here. Be like, hey, which regex are we using? Using the fancy one with the do's and don'ts, or the boring one? Yeah, Rask. Regex is good for string parsing. So when you get a string parsing problem or something where you need to do some string parsing in a quick way or even just an efficient way, right tool for the right job. Not one that comes up too often though, but when it does, it helps to know. Solve data false. Boom, still works. Now down here, return solve data true. Boom, still works. Okay, now it's just cleaning this up, really. I guess no, that's yeah. Different domains, I guess that makes sense. Must be a lot of a fair amount of string parsing or text manipulation then. Yeah. Good thing you know it then. True, true. Yeah, there's some regex in the front end, input validation, some stuff. Yeah, I don't end up writing a lot of front end or focusing a lot on front end, so it makes sense. So we got our conditional regex. What I'm gonna do is instead of abusing this map and doing some stateful stuff, just turn this into a real for loop. Last regex or last PR, use regex for auto detection of Jira ticket. Nice, yeah. That is relatively, I won't say relatively common, but a perfect use case for regex, honestly. Could be done with one bunch of splits, but regex is the right tool for the job. And yeah, I think I've used systems that use that underlying feature under the hood, just out of the box, but yeah, right tool for the right job. Why Why is this thing being all weird? It's like, hey, there are matches here. Boom, there we go. Made that happy. Then we say, so 2 optimizations. We're not going to return 0 and do all this weird stuff. We're just going to put the sum straight together instead of adding up the scores. And of course, Razgab, go ahead and get that sleep. Pleasure. Thanks for coming on back on out. Glad to hear you did. Got that 404. Yeah, have a good night. So we do need the enabled state, but then we need the total result. I guess just call this result. Real creative, this name. So if match starts with do, then continue on this. If enabled, we're not going to return. We're adding to the result. It's cool number. And then we can just return the result. Yeah. Pretty much like this. I could go real fancier here. I'll show what that fancy could look like, and I won't do it because nobody would like to read it. Basically, instead of destructuring these, I can have them become a product of each other. B initialized with 1. Yeah, so absolutely much harder to read. Does technically support more because it supports if you got multiple, multiply multiple together, but it's a little, it's not bad enough though. I'll leave it. I'll be bad. Okay, those are those two. Honestly, I think so. Yeah, I think what's really left is the regex and making sure this is clear what this does. So both of them end up calling this sim function, and our boolean determines which regex we use. The one that detects the multiplications, the do's, and the don'ts, or just the multiplications. If we are part 1, then we just want the multiplications. This enabled thing never ends up doing anything. So we just are always enabled. We're always doing the exact same result thing we were doing before. The optimization here is that instead of building up an array of individual multiplication results and then adding them up together, we just add them up together for a total result variable. But then if you are part 2 and you do have those conditionals, you have the regex that captures the do's and don'ts. As you go through the matches, if you find a do or a don't, you set the enabled flag to the appropriate value. If it's a do, true. If it's a don't, false. Then of course you continue to the next iteration of the loop because you don't want to look at this. You know, we could do something better. I was about to do an early return thing, but we need to detect those off. So this is actually the cleanest way of doing it. And yeah, that's it. So I think that's it for the code. I'm no regex expert, but I might as well show off how that works to make it somewhat clear on what incarnation's going on. So I'll use the 2 example since it has a lot of stuff in it. So first, we're starting a raw regular expression by having our regular expression within 2 forward slashes. We don't need these, but those i's were to make it ignore case or case insensitive. And the g's here are to find all instances, not just the first. It also means we return an array of matches versus a single match object. So I'm going to disable these to show what I mean by that. But if I were to drop the global from this one, we'll see we get a match object, which has the value match and has a bunch of other information. And if we were using groupings, then it'd have that too. but this only gives you the first one. In order to get the next one, you need to write a little bit of a while loop or something to that similar to keep going for more matches. That'd be useful if you really wanted to use the groups functionality or had other usages. We could have used that groups to not do this, but I didn't care about it, so I left it as global to just give me the array of matched strings. So that's the construction of the regex itself. What about the actual regex? Well, we're looking for the little literal characters MUL, as this explainer on the right tells us. Let's write some of these up. Then we look for the raw opening parenthesis. An opening parenthesis has a meaning in regular expression land, so we've got to put a backslash in front of it to escape it. And then \d, which is saying, give me a digit, which, as the hover says, is any character 0 to 9 inclusive. But we just don't want one digit. We want as many digits as you can get, at least 1 to as many as you can get. That's what this plus gives us. Between 1 and unlimited times of digits. As opposed to the star, which some of y'all might have seen in Regex land, which is 0 to unlimited times. But that would allow us to capture this illegal thing right here. That's illegal. We need at least 1 digit in here. The rule said it's at least 1 to 3 digits. But if I say, hey, it's a star, boom, it's not matching the illegal mul no more. Then we got the comma, which is for the literal comma. Another 1 to infinity digits. And the closing parenthesis. So, not the most complicated regular expressions, thankfully. What I ended up doing for the do's and the don'ts was doing some groups and saying, hey, find me any of them. Honestly, it's probably a better way I could have done this. But you can see the groups are matching to the things. Since I'm here, yeah, it turns out I did not need those big parentheses on the outside. I didn't need those parentheses. I didn't need those parentheses. Look at all these parentheses I didn't need. Maybe. I don't know. Let's see if it still works. It still works. Yeah, it's the power of regular expression. Like Rask said, once you know it, you can do a lot of cool stuff with it. Even if you know just a little bit of it, which is in my scenario, you can still do some cool stuff with it. And then use tools like Regex 101 and good examples to let you know, well, you have your assumptions, you get your theories, you make changes, you see what they work with. So those parentheses were doing things. They were creating different groups for them. So now they're all group 0, which is important if we were using groups, but we weren't using groups. So this just does the exact same thing we had before, but the or character says, hey, match this, or match this, or match this. So it basically said, hey, match any one of these 3. The reason we did it in a singular regular expression instead of multiple is because we want them to be in the order they are found in. And if we had just done like 2 different calls or 3 different calls, we would have gotten an array of mul, don't, and then do. We wouldn't have known the order they shown up with. We could have gotten that out by doing the manual matching, or doing the incremental matching and doing indexing and doing math. But that was extra work. And why do extra work when few work does the trick? So I think that's it, honestly, because the rest of these 2 regular expressions are just matching string literals. They're not even doing regex magic. Just gotta escape all the parentheses. So yeah, honestly, I think that's the end of this problem. I could see this being a fun one to visualize or work with. Not inspiring enough for me to go with. For those who are allergic to regex, this is of course still possible to do. It just makes the input parsing a little bit more effort, where you basically need to detect for every character. So you're basically just implementing your own regex finder or your own searching engine. You need to detect mul parenthesis. Then once you detect mul parenthesis, you need to make sure it's followed by at least one digit, a comma, at least one digit, and then a closing parenthesis. So not impossible, but a lot of effort just to say, or to, for whatever reason, not use regex. There are reasons, but for this such a problem like this, don't really see many. For the don'ts, they're string literals. Just the multiplication will be the fun ones to look at. I will commit this as that. And I might look into that. Don't know if it'd be that interesting though. Oh, where is it? Git law. There it is. Oop. Day 3. I'll give it a quick, like 5-minute attack. Parse moles for 0 I less than for less than beta dot length minus, and then the minimal length const minimal length is 1, 2, 3, 4, 5, 6, 7, 8. So I think it's a minus 8. 8, and then I plus. So it'll honestly be parse moles. L 1, 2. Now we'll see what the I outputs here. Minus 7, because it looks like we never hit 1. Okay, yeah, so I was off a little bit by 1, but there we go. We got that happy. So it's just making sure we run on proper indexes. So the first trick would be it detecting if the first 4 characters is MUL parenthesis. If so, then we can do the harder checking of things. So, if we're not using regex, then we're not. So my instinct is saying let's do data that slice from I to I plus 4, which would give me, well, I plus 4 would give me these characters, check if they're mul. That's making up a lot of memory in your brain. The efficient way would be x equals NUL like this. So for const CI of prefix, I don't get an entries here. Okay, so for 0 p less than prefix length p plus plus if data I plus p equals prefix p. So if it doesn't, then we're like, hey, you failed the city. So I guess the function will be there. Do has substring at index. Sure, I guess. A stack string needle string index number. Again, really just reinventing string parsing and string searching here, but if you wanted to, you could. Boop, there it is, and then index is I. So if it's not, then we'll return false. If you make it all the way through, return true. We're looking at haystack, not data. And it's true, not the TV channel TRU. So then we can do this check of if has that index. Then what is this? Haystack, which is data. Mul, well, prefix, but I might not variabilize it. Index. And we can see we've already hit that true. So that tells us, boom, we found it. Now what do we do when we found it? We start collecting digits. Digits equals, I guess we'll go an empty array. And then it'll be, first I have to make sure. Let digits start. So this will be another little function. Function collect digits. String start number. Now basically given a string, a starting position, and saying keep collecting digits until you can't collect digits no more. And then we'll need the index of when you fail to collect digits, which we can use the length of the number of digits you've collected to extract. So const digits, for const, well, nope, for let I equals start I less than string dot length I plus plus. If, and then we can do the old trick for detecting if a character is within two ASCII ranges. I'll put the character in a variable. Car equals start I, string I. So if car greater than or equal to 0 and car less than or equal to 9, then that's a digit. I might as well convert it. I'm not collecting digits just to collect digits. I'm collecting them because I want them as a number, but I need the digits specifically so that way I can figure out where I am. So I'm collecting them as digits right now, but I'll need to convert them to a number. And what will be the easiest way to do that? Mathematically, I can loop over them and multiply by 10, or I can just join them together. I don't have it memorized which one of those are more efficient. I'll do the lazy way of just joining them together, which means I'll push the raw character, and then I'll join, then convert to a number. Else, return digits. You didn't find them. First digits equals collect digits. And so we're going to do a little bit of math. It's data, and then it's the starting index. So we need to figure that out. So that's data I. Obviously, that's not it. I plus prefix dot length. That's it. So we have that. Now, do we have first digits, though? We do. There's a universe in which we don't, though. We got to account for that. So if not first digits, then we failed. We failed the city. And the trick about when we do fail, at certain points, we can fast forward. So if we've already seen the multiplication, then we can't see another, like we can't have m mul for a reason. So if not first digits dot length, then we continue because we failed, but we can set I to I plus prefix dot length, because what we could have walked into is another mul starting right here, which means we actually want to do -1 to handle that case. And then again, such a, not complicated, but there's some complication here. A method like this would have a plethora of unit tests and even fuzzy tests, to be honest. But let's say we do get some first digits. That's great. We want to now go to the comma. So comma lock, which is I plus prefix dot length plus first digits dot length. If I look at data block, I'm gonna see a comma. Boom. Okay, so let's see if, well, basically if it's not a comma, if 2 not equal not equal a comma, we have again a fail, which will allow us to do more fast forwarding plus first digits dot length and the -1 because we could start at the comma. I'm trying to think, since we're doing I equals I plus, can we just say I plus equal? We can. Boop, boop, boop. Boop, boop, boop. There we go, we can just do that. And now we'll get our second digits. Second digits, which will be more collecting of digits from data. But now it's starting at comma's location +1. +1? I mean, we'll find out when I look at second digits. Boom, we're getting second digits. Same thing in case they're bad for whatever reason. Second digits length. Move this to there. But now we have to add not just prefix length -1. It's all of these. Plus the 1 plus the -1. I'm going to keep all of it in there just for the readability of it all. Right? Plus the comma, but then go back to the comma. Well, to the character after the comma, because the -1 counteracts this. Okay, so let's say we got first digits. Let's say we got second digits. We're not done. We gotta get the closing parenthesis, or else everything is doomed. So this would be closing parenthesis lock, which is first digits length +1 plus second digits dot length +1. Let's see what's in data. Closing parenthesis location. It's not a closing parenthesis. Of course. Why would it be? Ooh, at this point, have I already modified? Nope, I haven't modified I. Interesting. Did I go too far? Okay, obviously I went too far by 1. Isn't that what I did for comma lock? Oh, for comma lock, I didn't do +1 at all. The length was enough. It was a +1 to get to the position of the first digit and the second digit. So I just completely hallucinated that. So this one's to get to there. Skip that comma. This one's unnecessary. Cool, cool, cool. Now we do same trick. Well, not a trick. Same check for closing parenthesis lock. If you're not a closing parenthesis, you know what we're gonna do. We're gonna fast forward you. Let me look at the pattern here. I took this string. Okay, well, I took this half of the string. I put it there with a -1. So if I just take this half of the string, I put it here with a -1, everything will be fine. Okay, I think we finally are done with the fun parsing of it. Who knows how many errors this has, but as you can see, Regex, it's a good tool to use, or else you're doing stuff like this. Do you really want to do stuff like this? And honestly, this is a relatively simple string thing we needed to parse. We did all that. Apparently we have numbers. We want to return them at some point, which we didn't even get to. We haven't even built one yet. So moles, I guess this will be an array, and I'll just return the important part. I'll return the exact part, because that's what the other one's doing. Boop, string array. So I will return moles dot push mole parenthesis . yes, at this point, we don't need to re-return the whole thing. We can just return the numbers themselves, do that, do some digit parsing up here. I'm not going to actually keep this code, though. It's just showing it for the sake of it. First digits dot join. Yep, and then second digits join. And then finally, return moles. We look here, we got one of them. And if we used it down here, you'll see we got some in here. And they're all being parsed out beautifully. So, this is why Regex is cool. Unless you are doing something that you need to do something extremely efficient or custom to the point that you believe you can do better than the regex multiplying or the regex matching engine that a lot of time and people smarter than us have put effort into making sure those work well. Use regex. Yeah, that is honestly as far as I think I'm going to take this. And let me not turn the screen to a rainbow this time. I'll try my best. Oh, okay. It looks like it's just me and one other person. So I'm not really gonna go do a raid and annoy someone. Twitch's got a bunch of people doing advent of code. There's a tag on it. Science and technology. Whoever is here, feel free to find another cool stream, someone doing some cool stuff. I will be back tomorrow to see what Advent of Code has for day 4. It's always a pleasure.